Alright, so today we're going to be going over how to graph tangent and cotangent. Our goal by the end of this video is that we're going to be able to graph those two functions. Okay, so we got to look at what the tangent graph is going to look like. And as always, we plot some points if we want to know what a graph looks like. So we've got some theta values here. Now a little bit different from the others we've been doing is we're going to start with some negative theta values. So negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. So when we're looking at negative angles on the unit circle, we would be going clockwise instead of counterclockwise. So we know that pi over 2 is here, so that means negative pi over 2, we go clockwise. And we would look at this point here, x and y value of 0, negative 1. And we know that tangent is going to be y over x, or in this case, negative 1 over 0, which is undefined. And then we can do the same thing for negative pi over 4. So here's pi over 4. If we want negative pi over 4, we would move clockwise to here. And we see that the x and y values is root 2 over 2, negative root 2 over 2. And we take the ratio, y over x, that'll be negative 1. So we're dividing by the same number. And then at 0, y over x, that's just going to be 0. At pi over 4, again, that is going to be positive 1. And then at pi over 2, here we'll get 1 over 0, which is undefined. So we can quickly sketch this out. We've got our theta axis here and our y-axis here. So we're going to plot negative pi over 2, pi over 4, negative pi over 4, and pi over 2. And y values we're looking at 1 and negative 1. Okay, so at negative pi over 2, tangent is undefined, so thinking it's going to be a vertical asymptote. Same thing for at positive pi over 2, tangent is undefined. Looking like a vertical asymptote. So negative pi over 4, negative 1, 0, 0, pi over 4, positive 1. So we're going to approach vertical asymptote but not cross it. And the graph's gonna look something like this. So it's got a little bit of a curve to it. It's not a straight line, and it's going to approach but never touch these vertical asymptotes at negative pi over 2 and pi over 2. Okay, let's look at the graph for cotangent. Now cotangent we know is going to be x over y because it's the reciprocal of tangent. And instead of starting negative pi over 2, we're going to start at 0 and go to pi. And we'll see why in just a second. But okay, so at 0, x over y, 1 over 0, we've got undefined. Same thing at pi, we've got negative 1 over 0, undefined. Let's look at pi over 4. That ratio, x over y, is going to be 1. At pi over 2, 0. At 3 pi over 4, negative 1. So our theta axis and our y-axis. So at 0, vertical asymptote undefined, and at pi, vertical asymptote undefined. Pi over 4, we're at 1, pi over 2, we're at 0, and 3 pi over 4, negative 1. And we're going to approach, but never cross the vertical asymptote. And same on this side. So that's what the shape of cotangent is going to look like. Much like tangent, but facing the other way. So here's some nicer graphs for tangent and cotangent. So this is tangent, and this is cotangent. So again, just like with sine and cosine, secant and cosecant, it repeats itself forever. So we see this curve from negative pi over 2 to pi over 2. We just copy and paste this to the left and the right. And for cotangent, this curve from 0 to pi, we copy and paste to the left and right. It goes on forever. So notice with tangent, the interval we like to look at is negative pi over 2 to positive pi over 2. For cotangent, the interval we like to look at is 0 to pi. So tangent and cotangent, they look very similar, but tangent goes up from left to right, cotangent goes down from left to right. Okay, so just like with the other trig functions, we can talk about transformations. So say we have y equals a times tangent of theta plus k, or y equals a times cotangent of theta plus k. So k, much like in the other functions, k is what is the vertical translation or the vertical shift. But more accurately, we like to look at where this middle point, these middle points shift. So for tangent, it's at the origin. For cotangent, it's at pi over 2, that middle point. So what k does is it shifts that middle point up or down. And what a does, so for a, what it was we looked at a being the amplitude, so the distance from the maxes and the mins to the midline. And we can think of it kind of similarly for tangent and cotangent. So we know that these nice points here and here at negative pi over 4 and pi over 4, it's just negative 1 and 1. And the same for cotangent at pi over 4 and 3 pi over 4, it's negative 1 and 1. So if a, we know that a stretches or compresses the graph. So if we're multiplying a to, say, tangent of pi over 4, which is just 1, a becomes that new y value. Same for cotangent. So we can think of a as being the vertical distance from the middle point for those two values that we talked about. So this is what I mean. Here we have the steps. So first we're going to set up our graph with the theta values. For tangent, we like to look in between negative pi over 2 and pi over 2, where those vertical asymptotes are. And for cotangent, we like to look at between 0 and pi, where those vertical asymptotes are. So notice that we're looking at different theta values for tangent and cotangent. And then we sketch the vertical asymptotes at the first and fifth theta values in this list here. We plot the k value at the middle point, which is the point in the middle, or the third theta value in these lists. And then finally, we can plot the other 2 points using our vertical stretch factor A. So let's put all that into practice and do some examples. So we know first let's sketch our axes. So the points that we like to look at: negative pi over 2, negative pi over 4, pi over 2, or pi over 4, pi over 2. So the midpoint, this k value here, ugh, that's so late, shifts the middle point down by 1. And this 2 is what stretches our points at negative pi over 4 and pi over 4. So at the middle point, in the middle, we go down by 1. So here, oh, we can sketch in our vertical asymptotes, forgot about that, at negative pi over 2 and pi over 2, because we're looking at the tangent graph. So middle point down by 1, and then the other 2 points at negative pi over 4 and pi over 4, we go up and down by 2. Now since the tangent function goes up from left to right, for negative pi over 4, we're going to go down by 2. And for pi over 4, we're going to go up by 2. 1, 2, at 1. This is at negative 3. And then we can sketch in our graph. So this one's it's much more steep. It's steeper than, there's not much curve to it, because that's what that 2 does. It stretches us out, so it's not much curve anymore. It looks more like a straight line. Okay, cool. Now we're looking at number 2. We're going to graph cotangent function. Y equals 1/2 cotangent of theta. So for cotangent, the points that we like to look at are in between 0 and pi. So pi over 4, pi over 2, 3 pi over 4, and pi. So we know that the vertical asymptotes are going to be at 0 and pi. And the point in the middle, which is right here, notice that our k value is 0. If we don't see anything and we don't see a constant added or subtracted, then we know that the middle point is going, or k is going to be 0. So we're not shifting it up or down by anything. So at pi over 2, we're still going to be at y equals 0. And then for the other 2 points, going to go up by 1/2 and down by 1/2. So pi over 2 negative, oh, cotangent, we're going to be, so for cotangent, we're going to be going down from left to right. So pi over 2 is going to be at positive 1/2, and 3 pi over 2 is going to be at negative 1/2. And this is really going to flatten out the graph like this. It flattens it out more. 1/2 compresses it. Okay. So just like with the other functions, if we have that negative in front, we're going to do a vertical reflection. So we know that the shape for tangent of theta looks something like that. The shape for cotangent of theta looks like that. So if we look at the shapes for negative tangent of theta and negative cotangent, if we reflect this, if we do a vertical reflection, it's going to flip it top to bottom. So it's going to look like this. And then if we take this, flip it top to bottom, it's going to look like that. So notice that tangent and negative cotangent have the same shape. And cotangent and negative tangent have the same shape. So when do we reflect? We reflect when A is negative. Just like we've been doing with the other functions. Oop. So let's look at what some of the graphs will look like. Okay, so for tangent, the theta values, we like to look in between negative pi over 2 and positive pi over 2. We have vertical asymptotes here and here. We see that the midpoint, or the middle point, we're going to shift it up by 1. So instead of starting at 0, go up by 1. And notice that the A value is negative 1. So we're still going to go up 1 and down 1, but we're flipping it. So instead of going up from left to right, we usually do, we're going to go down from left to right because we're flipping it vertically. So up 1, down 1, and that's what the graph will look like. So for number 4, y equals negative 2 cotangent of theta plus 3. We're looking at a cotangent graph. So the interval we like to look at is from 0 to pi. Our vertical asymptote is at 0 and pi. Our middle point, when we're looking at theta is pi over 2, usually starts at 0, but our k is 3, so we're going to shift it up by 3. And we notice that a is -2, so we're going to go up and down 2 from the middle point, but it's negative, so instead of going down from left to right, we're going to flip it and we go up from left to right. So from 3 we go down 2 to 1. From 3 we go up 2 to 5. It's going to look a little something like that. Okay, so we've got practice problems here. Graph each of these following functions. Secret word of the day is summer.